Suppose I have 3x plus 4y equals minus 5. And at the same time, I have x minus 5y equals minus 8. And what I'd like to do is solve this system of two linear equations and two variables at the same time. Okay, now what does that mean? Well, what could I possibly do? Well, notice that if I were to multiply one of the equations through on both sides by a number, it's not going to change the value of the equation. It's the exact same equation. If I take this and multiply both sides by 2 here and then 2 here, it's the same exact equation. So can I think of a clever choice of multiplying one of these through so that it sort of matches up in some sense with the top? Well, what if I just multiplied everything here through by a 3? If I multiplied everything here through by a 3, then what would I get? Well, what I would see would be a 3x, and then I have a minus 15y equals minus, and then 8 times 3 is 24. Okay, now let's just write down that first equation right underneath this. So I'm not going to do anything to the first equation, but you'll notice that these terms are exactly the same, 3x and 3x. Now the other terms aren't the same, I admit, but you have to admit these are. So what I could do now is take these equations and do some arithmetic or algebra to the equations by taking the top equation and just subtracting off the bottom equation. What if I do that? Well, if this is equal, these two things are equal, and these two things are equal, if I subtract this side from that side and that side from that side, these will still be equal, right? If 7 equals 7 and 3 equals 3, then 7 minus 3 will equal 7 minus 3. It's not going to change the value. But now look what happens, and I've got to be careful that I subtract every single thing, not just the first term. 3x minus 3x, they drop out. That's the idea of the elimination. I lose the x's. Now what am I left with? I'm left with a minus 15, but then I have a minus plus 4. So that's a minus 19y. And then I have a minus 24 minus a minus 5. Well, that's a plus 5. And so that would equal a minus, and I guess it's still 19. And now I can solve for y. You see how I eliminated the x? And now I can see that y would equal 1. Great. Now how would I find x? Well, I'd find x the same way that I did before. I would just plug in 1 into one of these equations and solve for x. So for example, if I plug in 1 into this one, you can plug into either one. So now I plug in and see x minus, and I put in 1 here. So 5 times 1 is just 5, equals minus 8. And so I'd see that x equals, if I bring the minus 5 over as a plus 5, minus 3. Oh, sorry, this should be an x. So x equals minus 3. So I just solved the system by elimination. I see that x equals minus 3 and y equals 1 is a solution. You can check, by the way. Plug in minus 3 for x and 1 for y. You'll see a 9 plus 4 is minus, minus 9 plus 4 is minus 5. That checks. And if you plug it back in here, you see a minus 3 minus 5 is minus 8. So notice that this is a solution to both of the equations at the same time. I did it by eliminating one of the variables. Let's try another one. How about 3x plus 2y equals 1 and 2x plus 3y equals 1? Well, this one's sort of a trickier one to sort of think about because it's not clear, should I multiply this by some number or that by some number or something? There's a variety of things you could do. You could multiply this through by a particular fraction. That's a good way of doing it. Or another way is to multiply this by something and that by something else, and then have things line up. So for example, let's suppose that I want to get rid of now, just for fun, let's get rid of the y's. Notice what happens if I were to multiply this by 3, that would give me a 6y. But then if I multiply this by 2, then I have a 6y here. And if I subtracted, they would drop out. So what I'm going to do is I'm going to multiply the top equation by 3 and the whole bottom equation by 2. It's not going to change the value of the equations. It will change the sort of the look of the equation. But so what? Here on the top, I would see 9x plus 6y equals 3. Notice how I multiplied everything through by a 3. If I didn't multiply this side by a 3 here, it would change the equation. Now I'm going to multiply everything through by 2, and I see 4x plus 6y equals 2. And notice I have a 6y and a 6y. They match up perfectly, so I can actually subtract these two from each other, and I'll still get a true fact. And I'm going to now eliminate, that's why it's called elimination, eliminate the 6y. So if I take 9x and subtract 4x, I'm left with 5x. 6y minus 6y is 0, and 3 minus 2 is equal to 1. So I see that x equals a fifth. So there's the x value. How can I find the y value? Just plug in that x value into either of these original equations. Either one will give you the same answer, and you can solve for y. For example, suppose I put into this bottom one here. If I put x equals 1/5, I would see 1/5 times 2, so that's 2/5 plus 3y would equal 1. If I bring the 2/5 over to this side, I'd see 3y equals 1 minus 2/5. But 1 is 5 over 5, so 5 over 5 minus 2 over 5 would be 3 over 5. If I divide both sides by 3, I'd see y equals, well, now I have to invert that 3 over 1 and multiply. Now watch what happens here. You invert, whoop, it becomes 1 over 3. But 1 over 3 I can cancel, and I see 1/5. So that's sort of fun. The x and the y values turn out to be the same. But if you plug them back in, you will see that, in fact, these are satisfied, right? 3/5 plus 2/5 is 1. And 2/5 plus 3/5 is 1. So in fact, I found the solution by this time using the elimination method, where I multiply equations through by appropriate numbers so that, both sides, so that one of the variables lines up. If I subtract, they eliminate, and I can solve for the other. Try some of these elimination problems on your own.